Welcome friends, welcome to JCE Connect. Today we are going to derive a scale of a vertical photograph. This is derivation 1 of a aerial photogrammetry. In previous class also we have discussed about this derivation, and today again we are going to discuss this in clear so that we can have or we can solve few problems on this. Now here the ground is horizontal, that is all points are having same elevation or may not be. Means here I am going to consider two cases. Case 1, all points having same elevation, and case 2, points are not having the same elevation. Now here I have written those cases. Here this is case 1, and here you will be having case 2. Case 1 says that all points are having same elevation, and case 2 says that points are not having the same elevation. In these two cases, how to determine the scale of a vertical photograph? In general, now if you take in general, the scale of vertical photograph will be, it will be right here I have written that formula: scale is equal to map distance divided by ground distance. It means that whatever distance you are going to measure on the map, that distance if you divide with the actual distance which is there on the ground, then that will that will give you the scale. Now here I have drawn two different figures. One figure is for the points having same elevation, and second figure is for the points having different elevation. You can see that point A is differently located with respect to point B, whereas in this figure, case 1, here will be having only one point that is located on a flat ground. So how to get the scale of these things, that what we are going to see in this problem. Now here if you see this figure 1, now if you see this figure, we are having a ground point A, and the distance between the datum and a ground will be your h. Here this k stands for a principal point on the ground, whereas this small k stands for the principal point on the photograph. Now here you have to understand two things. One is, here this is the photograph and this is the ground. Now the same thing I'll be locating here. See, this A point is going to located here as a small a, whereas the projection of A naught which will be there on the datum is going to be here at A naught. The K is the principal point on the ground, is going to be small k on the photograph. Now the distance from O to K is F, whereas the remaining distances, see the distance between the datum and ground, this distance, right, this distance is h. Now the total distance from the station exposure, that is exposure station to the datum, is h. Now this is your h, right? Now if this is h and if this is small h, then this distance you can easily get that distance, that is capital H minus small h. Now this is what for the case 1. Now here you can have the property of a same triangle or a similar triangle, and then you can get the things done from this figure. So we'll see that by referring this one figure, case 1. Now if we take case 1, let us first take the case when the ground is horizontal, that all points are having the same elevation. In that case, as I said, that the scale, how we define scale, that is map distance divided by ground distance. Now if you take the two similar triangles, that is OKA and capital O, capital K and capital A, if you take these two triangles, then what you are going to get is, see, small ka divided by capital K, O small k divided by O capital K, right? So these will be, we'll see in the figure how these things will be there. Now what we are going to do is that we are going to take two triangles. Now this is OK and A, this is first triangle, and then one more triangle we are going to take, O capital K and capital A, two triangles. Now based on the similar triangle properties, what you will be having, see, this side divided by small ok divided by capital OK this side. Similarly, KA divided by K this side, that you can do there. Whereas small OK is your F and capital OK is your H minus H. These two things we are going to use there. Now here that is small k divided by capital K, small OK divided by capital OK. That is, as we seen in the figure, that is F divided by H minus H, since S is equal to F divided by H minus H, where H, capital H is the height of exposure station above mean sea level, where F is focal length, and small h is the height of ground above mean sea level, right? So all these things we haven't seen in the figure. So this is first case when you will be having the same elevation, then you can have S is equal to F divided by H minus H. This is the formula for scale when all points are on the flat ground or having the same elevation. Now before going to the case 2, that is case B, you just understand the figure what it is there. We'll be having two locations, A, 2 points, and here it is B. Both are located at different elevation. Now what are things will be there? Now this is we called as KA, this is we called as KB, and this is the distance from exposure station. H minus HB will be the distance from exposure station to the point, whereas the distance between the datum and ground towards point B is HB. Similarly here the distance between datum point and the ground is HA, whereas the distance between point A and the exposure station, that is H minus HA, and the distance of exposure station above mean sea level is capital H. Now with respect to this, see here also you can compare the different triangles, similar triangles, and you can get the things done. Now let us take the case when the points are not having the same elevation as represented in the figure B. Let A and B be the two points having the elevation HA and HB respectively above mean sea level. They are represented by small a and small b respectively on the map, whereas small k is the principal point of a vertical photograph taken at a height h, capital H, above the mean sea level. The scale of a photograph at an elevation HA is evidently equal to the ratio Ka small ak divided by capital Aka by similar triangles. See here two triangles AKO and the triangle capital A capital KAO. By these two triangles, what you are going to have there? See, you are going to have AK divided by AKA, that is OK divided by OKA, that equals to F divided by H minus HA. Hence the scale of a vertical photograph at an elevation HA is equal to F divided by capital H minus small HA. Now similarly with respect to the height B or elevation B, HB, right, the scale of photograph at the elevation HB is equal to the ratio of here small bk divided by capital BKB. From the similar triangle BKO, that you are going to compare with the capital BKBO, right? So you will be getting BK divided by BKB, OK divided by OKB, that is nothing but F divided by H minus HB. And hence for scale of a vertical photograph at a height HB is F divided by H minus HB. In general, you can write the scale of vertical photograph as, see here, SH, that SH means scale at a elevation H, that equals to F divided by H minus H, capital H minus small h. Now the scale of vertical photograph can be designated by the representative fraction also, that we call as RH also. Right here, if you see this here, as I said that now you will be having different dimensions, right? So one will be either in mm or centimeter, and the denominator will be either in meter or in kilometer. You will be having different dimensions there for scale. But when you will be talking about the representative factor, now the denominator and the the f value and the denominator, that is f and h minus h, both are having the same unit. Both should possess the same unit. That is the condition for this representative factor. That is the difference between the scale and representative factor, that both the values, right, that is h minus h and f, both are both are in same unit. Both should be in the same unit. Then we are going to call it as what? Representative factor. That we have to keep in mind. Now here I have shown that representative factor. See, you can see this representative factor, how you can represent that. That is RH is equal to 1 divided by capital H minus small h divided by f. This is the representative factor. This is very important, that you are going to get some of the question on representative factor and scale. Now some of the notes that you have to keep in mind before going in further, or before going to the few more derivations, that first, datum scale. What is datum scale? That you have to understand. Now that datum scale we can show here, that is SD is equal to f divided by capital H. The datum scale of a photograph is that scale which would be the effective over the entire photograph if all the ground points were projected vertically downward on the mean sea level before being photographed, thus from figure A. So this we have derived from figure A, that just you remember the formula for the datum scale, that is SD is equal to f divided by capital H. Similarly, average scale, that is SAV, that equals to f divided by capital H minus small HAV. Small HAV is the average elevation of the terrain. That now this average scale of a vertical photograph is that which would be the effective over the entire photograph if all ground points were projected vertically downwards or upwards on the plane representative, right, that representing the average elevation of terrain before being photographed. So you can get the datum scale also, you can determine average scale also, right. These two you can do. Just remember the formulas for these two. Now next is scale of photograph. If the image of a ground point on on equal elevation or no equal elevation and known horizontal distance appears on the photograph, the scale of photograph can be determined by comparing the ground length and the corresponding length on the photograph. These two things you can do. See, whatever length will be there on the photograph, that you have to measure, and that you are going to divide by the length what you are having on the ground, then you are going to get the scale. Thus, if small l is the distance on the photograph, small l is the distance measured on the photograph between the 2 points A and B having the same elevation H, and the horizontal distance or the ground distance between them is capital L. That capital L is the distance which we are going to measure on the ground. Then the scale at that height is given by SH is equal to L divided by capital L. So this is the scale of a photograph. Dear friends, you all of you have drawn, or if you have gone with the drawing classes, you might have learned in the AutoCAD also, if you are having that lab now, so that how to get the scale, right. If you go to the plane table surveying, there also you are supposed to convert the things, that we are going to convert the ground details, and we are restricting the length and we are drawing it on the sheet. So that scaling you should know. This is very important aspect of a drawing, and being a civil engineer you should know all the aspects of drawing. This is the first derivation of aerial photogrammetry. This is what all from my side. I am Professor Balasaheb Jamada. Thank you.